Well, I got a little preamble, so I'm going to start. And then, all right, so while my Docker desktop gets itself up and running. So who uses Docker Compose for local development? Anyone? No one? All right. Those guys. Windows users? Linux? Macs? Yeah. Kubernetes? Yes. Okay, great. Good. All right. Who uses Helm charts? Cops? Customize? Anyone who edits manifests directly using Vim? No. Oh yeah. Great. Good. Excellent. Yeah. So hopefully things will get a little bit better. Still waiting on Docker. Docker's hung. Docker desktops killed me again. But that's not real. That was my MacBook Pro. I use an iPad. But that really sort of looks at the reasons behind this talk today, right? Is that Docker desktop on a Mac, yeah, it works really well, but sometimes it doesn't, and so it completely interrupts my development flow. It stops my team from being able to develop software, and it's a total pain. So what I wanted to do is to be able to provide a development environment to my team that was just as easy as using Docker Compose, but only having the process on my laptop or my virtual machine that I'm working on and not everything else. So I'm Mark. I'm a developer evangelist with DevCycle. We're a feature flag management tool, and I spend most of my days talking to development teams about how to utilize feature flags in order to improve their CI/CD pipelines and be able to improve their developer productivity. Over the last 20 years, I've been pretty much in development leadership, running teams from 5 to 50 people. And most of the time on those teams, I'm the one who's responsible for DevOps, and platform engineering, which I've been doing for well before we had the term DevOps and platform engineering. So I started this journey back in 2010 when one of my colleagues, Tim, turned around to me and said, we're never going to rack another server again. And so that kind of started my journey in cloud computing, which led me into Docker, which then led me into Kubernetes. Kelsey just talked about philosophy. I call these my 5 things. This is my philosophy. So these are the 5 things I feel that I, as a development manager, need to bring my team. Right? Automated testing, CI/CD pipeline, feature flags, centralized exception management and logging, and what we're going to talk about today is an easy-to-use development environment. For me, these are the key things that make my development teams more productive, more efficient, and most importantly, more happy. Right? Because we all know that if you have a development team of happy developers, they're going to be better at what they're doing. So today we're going to talk about an easy-to-use development environment, and these are things that usually get built organically. Usually you start off at the beginning of the project, you kind of set up a few things, you leave it, and they don't get the care and feeding that they deserve in order to work for the team. And as developers, we endure an enormous amount of pain when it comes to things like development environments. We've all cloned that repo from the company we've started working at, and it's taken us a week to get it up and running, right? And you have to talk to Bob, in another building that has the secret code to be able to actually make it run. To me, as a developer, what I wanted to be able to do is literally read the README, run a couple of files, and I'm good to go. And so that's kind of my philosophy behind an easy-to-use development environment. My talk today is about the journey I went on from going from Docker Compose to utilizing Code Zero and Kubernetes. So it doesn't matter if my team, whoever's on my team, whether or not they're a front-end developer, writing microservices, machine learning, whatever, it should be easy for them to be able to use. Like I said, I want to be able to read the README, I want to clone the repo, read the README, run some commands, and that's it. Right? I should be up and running in minutes, not weeks. And I should be able to bring whatever IDE I want. I was just talking about, I'm a Vim user. I should be able to use VS Code, Sublime, Emacs, like whatever I want. I shouldn't be said, oh no, you have to do it this way. I'm like, well, that's not my flow. right? I do it this way. I should be able to bring commodity hardware that I want. I shouldn't have to, every time we add a new microservice, have to go out and buy my developers a new laptop. We shouldn't have to be running 64 gigs of RAM on our workstation in order to run our app, right? We should be able to survive on 8. And as a development manager, also, as I was saying, cost is key to this, because the more that I have to ask my CFO for money for laptops, the harder it is for me to want to get more developers, right? So if I can say, listen, all we have to do is just, we hire them, we give them an iPad Pro, we give them a MacBook Air, and they're good to go, that's great, right? I don't have to go and buy them specific hardware to do specific things. So where did I start my journey? Well, for the last 8 years, I've been addicted to using Docker Compose to be able to do my local development environments. Even after having started using Code Zero, I still revert back to this because this is what I know. This is easy for me. And if you've ever used Docker Compose, you're like, well, it doesn't matter what I need, whether or not I need a database, I can add that. Redis cache, I can add that. OpenTelemetry, whatever I need can go in here. Other projects that are inside my organization that build down to a Docker file, add it in here. If I need local AWS services, I can put in local stack. Everything can go into a Docker Compose file. It's fantastic. It works really well. And all I need to do is run Docker Compose up -d, and poof, I have my entire development environment. I got everything I need. You can script everything in your startup, whether or not, mostly these days I do a lot of front-end programming, so it's a lot of yarn, a lot of NPM. I can do an NPM, I can do a NPM install, and that can preload my database. I can get everything set up. It's really easy to do, but there are some problems. After a while, there's too many processes. When I was working at Hootsuite, we had a Monolith PHP application which ran on the developer's desktop for years. It was great. You just cloned the whole repo, got it up and running, local database, local cache, poof, it was easy. And then we started to decompose it into microservices. So we went from a single PHP monolith to hundreds of Scala microservices running on Java. Took the developers' laptops to their knees, right? You couldn't do it anymore. So our solution at the time, so this was 2014, was to build a development cluster, so that the developers, all the microservices ran on the developer cluster, and then you ran what you wanted locally. It worked, but it was a lot to maintain for the team that I ran at the time. Right? Not only did we have to worry about production, we also had to worry about development, and then of course, all the things that got associated with that. Not everybody runs a monolith. If I have multiple projects, an API and a web, and they both have a cache, now if I run Docker Compose up, all of a sudden, poof, I got port conflicts unless I change the port inside the Docker Compose file. So now I have to go look at the Docker Compose file about what port that Redis cache is running on, and then now I'm into this whole different configuration. I can't use the tools natively as I want. Docker Desktop. That video I showed was from me trying to use Docker Desktop on my Mac just one day. I didn't set it up, I didn't script it up, I didn't, run a big process in the background. That's just what my work process looks like some days, is me fighting with Docker Desktop. I do a lot of my development on Linux, and Docker on Linux works really well, as we probably all know. And it's not that it doesn't work, I don't want to slag Docker too much in here, but it doesn't work perfectly, right? And again, as a development manager, I don't want my developers futzing around with, where did it go? Wow, the timeout's too short on my laptop. Forgot to fix that. I don't want my developers futzing around with processes, right? We don't want to sit there and have to wait. We don't like when our compile time takes like 2 minutes to build something. We all sit, if you're a React developer like I am, you hate when you hot reloading doesn't happen instantaneously, and you have to wait like 5 seconds for that little change you just made to be able to see it. Anybody running Docker Compose in production? No, no, we don't use it in production. So now my team has to learn something for which we don't use in production. So why not take all that learning that I want them to have? I want my developers to be using Kubernetes. I want them to be so comfortable at using it that it's just second nature. So why don't we use that locally as well, so you have that experience from sort of the beginning of your development process all the way through. So I need to replace Docker Compose, but I have some constraints. It's gotta be easy. Like Docker Compose up -d, like how much easier can you get than that? It's all in a configuration file. The configuration file is all in version control. If someone makes a change, you can see it, right? It's all there. You got connected services, you got volume management. Does this have a wait? That has a wait in it so that I make sure all my services are up and running before the process exit, so that I know that my database is running, it's been populated properly and built. It's, this particular configuration, it'll create that database if the database doesn't exist. So you can do, Docker down -v and blow away all your volumes, start again. Like this is a really nice workflow. So I can't go back to my developers and say, hey, I know that lovely workflow I just took away from you. Now I got 27 things for you to do. No, it's got to be easy to use. So where I ended up after a lot of time was utilizing Code Zero and Civo. So Code Zero provides the networking layer so that I can connect to all these services remotely running in my Civo Kubernetes cluster, right? Why Civo? Well, Civo is really easy to start up, right? My developers don't need to be Kubernetes experts to be able to do it. They don't have to understand anything other than how to use the Civo command line, which is pretty much, Civo K8, create, give it a name, right? And that's it. There are costs associated, obviously, with running Civo. It's not free. But to me, there's a balance between the amount of hardware I need to provide my developers, a fixed capital cost, and then the ongoing operating costs of developers having their own Kubernetes clusters. You can also then work on how to keep those costs down, right? We've all left a cluster on for a weekend and have all come in the morning with, Monday morning with someone saying, you just cost us $40, right? And you're like, well, yeah, I'm sorry, I won't do that again. And so you can build up all that learning and how to manage this over time. So before we kind of dive into a demo, what does this look like architecturally? So Civo on the top, straight up Kubernetes cluster. It can be any Kubernetes cluster. We're here at Civo, let's use Civo. This can be, doesn't matter what it is, right? It's just good old fashioned Kubernetes. Local machine, so the kind of the key thing that Code Zero does is it deals with the packets at the DNS level. So normally when you do Docker Compose, you're calling localhost, right? And then a port, right? Which is where you end with port conflicts. Well, the only place we use localhost is in local development. Like in our Kubernetes clusters, we call everything by service, right? And so the DNS works the same way. So that there's a DNS intercept that's happening that says, if this is destined for the Kubernetes cluster, I'm going to take that packet, I'm going to send it over here, but I can use it by DNS name, which means I can have different Redis caches running in different namespaces, and it'll all work out. All right, so the demo I'm going to show today is relatively straightforward. This is the kind of application that I build. Redis cache, Postgres database. I'm a big Next.js fan because it gives me an API along with my React development, so I don't have to have so I don't have to have two projects. Right? Just puts it all in one. It's like having a monolith, but not really having a monolith. I originally thought that this was kind of too simple of an example, but then I went back and looked at all the projects that I've worked on over the last year, and pretty much this is what I built. Right? These are the two things, other than if I'm using SNS or SQS or some other ingrained AWS service, like these are the only things I put on. So let's take a look at a demo. So this is me connected into my remote Mac. This is an ARM64 Mac running in the cloud. ARM will actually become important in the case study. So we can just take a look at, let's see what we have in the way of Civo. So I have my Civo, yeah, I call it Civo again. I got corrected by Dinesh, the CTO, yesterday. Very politely. He was very nice about it. He just looked at me and said, Civo. Very, 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 very nice. So it's up. So I have my Civo cluster up and running. So that's all easy. So I can look at my current context. Right. Okay. So I got my kube config running properly. That's great. Right. I'm a K9S user. I don't know. Anyone else use K9S? Yes. All the command line people I love this tool because, again, my development environment is Tmux and Vim, right? So I don't need anything else. So poof, this looks very, if you've used this tool, this just looks very similar. I love it. It's all there. So that's up and running. I can get my nodes. I can see that. Oop. Poof. All right. So good. Okay. So that's up. So I have Code Zero running. You can obviously tell I alias everything because I hate typing. So I aliased CZ cuddle to CZ, and I can look at the status of that. If I can spell status properly, we're good. And a little less debugging than Narayan showed yesterday in his demo, but it's up and running. So the process in the background that is going to intercept the DNS and then the port requests to go to the cluster is all there. So that's good. So you might be saying, well, why don't you just use port forwarding, right? Your local development. Well, so yes, I've used port forwarding, and I still use port forwarding on some projects because I'm lazy and haven't moved everything over yet. So port forwarding is great until it's not great. So you get port conflicts again, right? Because it's localhost. So if you have two different web servers running on port 3000 in different namespaces, you can't deal with that. And it connects directly to a pod. So if your pod goes down, your network connection. So when I would use port forwarding, I would forever be restarting port forwarding, right? And that's not a good development experience because you're like, oh, why doesn't this work? And then you're thinking the 1,000 things of why I can't connect to that. Well, the proxy being down is one of them, and maybe the third thing you try. So it takes a bit of time to debug that. So this, you don't have to worry about that. It manages everything for you in the background. If the pods go away, it doesn't matter. It will reconnect to that. And also, if you have sort of like horizontal pod autoscaling turned on, and you have it, and I'll show you an example in a minute, it will connect to the pods. You don't have to worry. The pod could scale down, and this will still continue to run. All right. So as I said, I'm a pretty much a Helm user. Been working on over the last couple of years converting everything I do to Helm. Because it's nice and programmatic, it's easier for my developers to get a hold of. And so in this case, I'm just using Helm file, which is a chart of charts. And if you've used it before, if you haven't used it before, this is great because I can sit there and define, just like I do in my Docker Compose, I have a database and a Redis cache. I have Prometheus up there as well, but I've said, nah, don't bother deploying it. So if I want to deploy it's quite simple. It's a Helm file apply, with only 2 P's and no U. And this basically just runs Helm, right? So I could do this by just typing Helm, but just like with Docker Compose, I used to be able to just type Docker and I could connect everything together with a series of Docker scripts. Docker Compose came out and said, hey, we have a YAML file for you. Helm file, this is a YAML file for running multiple Helm charts. So poof, I'm up and running. So there we go, I got my 2 charts, I got my database and my Redis cluster up and running. So I can put it in a, CZ, the Z is there. Greatest course I ever took in high school was keyboarding. I'm old enough that I did it on IBM Selectrix typewriters. So here we go. Are we up and running yet? No, we're still pending. It'll take a minute to get going. So bear with me for a sec while this gets up. But what I'm going to be able to do now is I'm just going to be able to connect to my Redis cache using Redis CLI. The host name is going to be Redis master, which is the name of the service. And if I want to, I can attach the namespace as well. So I don't have to put a port. It's default port. List my keys. Maybe it's not ready yet. This is why DD didn't do a live demo. Because she knows that it doesn't always work. Oh, it did CA again. Yep. Dun, dun, dun. Oh, it says they're run. Oh, 3 seconds ago. Okay, so maybe let's see if that'll work. Yeah, so no keys, so I can set. I really do make a lot of typing mistakes. There we go. So I have a Redis cache, right? So again, this is running in the cluster, right? It's not running on this local machine, right? So if I can look, we can look at the namespace or the process space and it's true. And the same thing with my database. It's all running there. So if I look at K9S, right, there we go. Okay, replica 1 hasn't come up yet, so it's just taking its time. Kubernetes is doing its thing. It'll get there eventually, but I have these processes up and running. So now I can connect my local development environment to this, right? And all these processes are running out there. So it doesn't matter what else I get running, I can connect to it. So let's look at Code Zero. So I can attach to the list, and I'm going to filter by my namespace, and it's going to show me these are the processes and the ports and the names that it's connected to. So it's doing all that work under the covers for me so that when I make a request on a particular DNS name and a particular port, it'll then send it over to the Kubernetes cluster. If I make a request to Google or something else, the DNS will send it over there. So it manages it all for me. So it's nice. It's nice and easy. So I've gone from kind of one process, Docker Compose up -d, to kind of two processes. I have to get, I have to run the Helm charts, which I think is actually really great because now I'm pushing my developers to using Helm from day one, right? Build me Helm charts. Don't build me Helm charts at the end of my project. Build me Helm charts now, right? Get used to using Helm, right? It's a great, very powerful programmatic language for doing manifests. And I get to call them by name, right? So now we talk about Redis, we talk about Postgres. We don't talk about localhost :5432, right? Like it's all, we can talk in that kind of language. So everything I set up is around that. So you don't get stuck with, we've all gone and tried to debug a production project and you grep for localhost to this on the production server and you're like, oh damn, someone's left localhost in there. No wonder this is not working, right? So we get away from that. So you might be thinking that, well, that's a nice, simple, cute little demo. What about the real world? So this is a case study for a project that Narayan and I worked on for a while. So this is a company called Enval. They are a financial services AI company. They are able to utilize a machine learning model to price thinly traded assets, which means they price NFTs. Right? Not a lot of transactions on each NFT. Thinly traded, it's not the stock market. And so they're able to predict that. So they have a giant machine learning model. They grab data from the blockchain. They have a giant machine learning model which produces the models, and then they have an API that you can connect to and ask how much this NFT is worth, and it'll tell you within a certain confidence. Now, it all works, but it all works on AMD 64. You cannot take their Docker Compose file, their Docker file for their machine learning system and run it on ARM. It does not compile. After spending a day at it, I said, screw this. I'm wasting my time. I need a different way of doing it. So I had choices. So I could run this I could spin up a cloud server and I can run the whole process there and do cloud development. Yes, that works. That's how I started. But I'm like, well, it works for me, but I've been at this for a long time. I know I'm very comfortable with using Linux, with spinning up servers, not a problem. What about the rest of the development team who are, anywhere from a junior developer with 3 months experience of writing code, to a machine learning team who is not really as comfortable in Linux as I would like them to be. So how do we make this easy on them? So utilizing Civo and Code Zero, I was able to take the Kubernetes manifest, so we were using Compose at the time, and deploy that to a Civo cluster, and now and then using Code Zero to expose the ports that I needed for the services that were in there. I could get it up and running. So let's take a look at that. So, all right, So for those of you who are familiar with Compose, these are the manifests. So Compose just brings a group of manifests together and it will combine overlays on top of it, so you can have a dev overlay and a production overlay. It's sort of cheap Helm charts. If you're good, do a lot of manifest stuff, this is I think simple This is where I started with this project. So we already had this existing, so all I had to do was create an overlay specifically for development, for local development, and then, and if I go back into K9S, we'll actually see that I have them running down. Oop, that was wrong. They're down here. So we have a number of different pieces. We have a web component, a worker component, Postgres database, Redis cache, all the things that are needed for it. The worker is actually quite important because this is where the machine learning is actually done, and it does do horizontal pod autoscaling. So if you spin up, say, hey, I want to train 6 models, it will actually spin this up and run 6 of these, and then deal with bringing up more servers on the back end if it needs to. So not only can I run this without having to bring my poor laptop to its knees, but it'll also scale up nicely, right? So if I want to if I need to train a bunch of models, I can do so quickly, so I don't have to sit around and wait for that to happen. But the really key thing to this is that I can actually call the tools utilizing, let's see here. So this is, so the web app is running by name, so it's nval LTF model web, which is the web server. I gave it a namespace, port 8000. It's, so this is a Python Django app, so you can get the data. And then we have a command line tool that allows us to actually go and get price predictions. So this whole model, although I'm running on ARM64, it can't run on ARM64, it's running on AMD64. I can run this whole system, and I don't have to run it locally. So I can be the API developer or the web app developer, and I can have my own machine learning model running specifically for what I want to do. Machine learning guys, obviously, when they're developing this, need their own, they have Windows machines to do this, but this now works for me utilizing these tools. So these are kind of the lessons that I've learned in going through this. Like I said, this has been a multi-year journey into kind of getting here. Everybody keeps telling me that Kubernetes is hard to use. It's a big product. There's a lot in there. Rolling it yourself is hard to use. Civo makes it easy. Other cloud providers make it easy. So it's not a hard product to get going with. You can create simple manifests. You can borrow people's Helm charts. You can learn from the community. Getting developer buy-in is kind of critical to this. So I replaced their one command, the Docker compose up, with one YAML file with a Helm file apply and a YAML file, and then a Code Zero CUDL start. Right. So I haven't really added to their workflow. This is I started up Code Zero 5 days ago on this machine. I haven't restarted it. It just runs, right? Which is exactly what I would expect, right? So from a developer's perspective, I haven't had to futz around with this at all, right? Which is what I want. I don't want my developers having to sit there and waste time. Like nothing's worse than sitting there going like, why doesn't this work? And you realize that it's just something has crashed. Run out of disk space, whatever the problem is. My developers can now create Helm charts from the beginning because everything deployed into Helm, so whatever you use. So I'm using Kubernetes right away. It's not like, oh, by the way, we're now done our project, now let's go to Kubernetes. It's like, let's start from the beginning, right? If this is going to be our deployment environment, let's go there. And we can also continue to leverage the community, right? Those two Helm charts I used for Postgres and Redis, those are just community Helm charts, right? Like I didn't build those myself. I just utilize that. So we have everything that's out there today that you use in your cluster from the community is there available to you right now. There are still some problems that remain. This is not a perfect solution. You can have runaway costs. You can leave these up and running. They will cost you hundreds of dollars a month, right? So you have to realize that that's still a problem. However, and a laptop is a fixed cost. Once you've bought your laptop, like you don't spend more money on it. It is what it is. If your networking is slow, which it can be, so if you're like me, a remote worker, you sometimes work in places with unideal Wi-Fi, this doesn't quite work as well because obviously it's using the network, running it all locally, no network needs, you can do development. So that's a bit of a problem. However, you know, Starlink has changed the game for anybody who works remotely, right? You can buy, particularly where I live in a pretty rural community in the west coast of Canada, and people have Starlink, right? So you can be off-grid with a solar panel and your Starlink. So, you know, the game is, you know, over time the game is changing. Networking is getting better. And it is another thing for your developers to manage, right? You know, they already have the burdens of, you know, can you do all these things for me? Now you have to, learn some more tools. So yeah, so there is a bit more overhead for that. And that does come at a cost. All right. Well, thanks. This is my contact info. I'm Mark C. Allen on pretty much on everything. So if you have any questions, please do let me know. If you have any sort of environments that you might be interested in trying to see if this will work, if you want to try and stump me on this, Narayan, the CTO, is here as well. Try to stump him on this. But are there any questions? Anything anybody wants to know? We're good? No? Yeah?
I think when you were referring to compose, I think you were talking about customize. Is that correct?
Oh, did I take? Yes, I meant. Okay, sorry. Yes, that was customize.
And the Helm file was effectively what your Docker.
It is. Yeah, it's a chart. It's a chart of charts. I had very simple configuration in there, but any set command you want will just go into that. So it looks so more complicated ones look just like a Docker Compose file, right? You can tell them apart, but it is very much the same thing.
How hard was it to translate your Docker Compose to the Helm file? I guess what you said there, sorry, you had to hand tune it with the Helm file, and I'm not familiar with that tool. You were just using community charts, aggregating them. Is that correct?
The Docker Compose file was also those were community, Docker Hub projects, right? They were very standard. It's again, my Docker Compose files are not that complicated, right? Like I said, I went through and looked at a bunch of projects that I've worked on, and quite frankly, it's a cache in a database, right? And a few other things. Like maybe if you get into OpenTelemetry, you start putting up a few more things. If you have Prometheus in there, right? Because you're doing some sort of statsd importer to make sure that you have the right analytics. Maybe that gets a little more complicated. But like many things, it grows organically over time. And if you spend sort of the time to make sure that it's right, it works, right? And I'm also big on going back to, using what the community uses. I don't have to roll everything myself. I do know how to build my own Docker files in order to get things to run, right? Like, see if someone else has done it. Like, there are people that are way smarter than me out there who are publishing stuff to GitHub, Docker Hub on a daily basis. Let me use their stuff. It's way faster. All right. Well, thanks, everyone. Thanks for... Oh, sorry. Yeah.
Well, I was just going to ask you, this was an example of running basically individual test environments, right? And you've got the example where they're using something available on the internet, or it's, say I want to use something in your test cluster to be able to test, you found a problem, vice versa, but then I want to use everything else in mine because I've got a computer.
Yeah.
It's that kind of that ability to cross the boundary of the Code Zero piece, I think.
That's correct. Yeah, and we have also traffic shaping and conditional traffic shaping, where you could actually say, for this service, I want to use Mark Allen's variant that's running on his computer, and someone else may be saying, I want Alex's variant, for example. So, and those traffics don't collide.
Yeah. One of the really cool things that we can do, and I didn't talk about it here, is, so normally when you're developing, rarely are you just one developer, right? There's always a team, right? So if I'm a front-end developer and I'm working with Andrew, who's the back-end developer, and we're working on pretty much the same ticket where he's building out the API or making changes to an API that I need in order to update my front-end change, right? I have to wait for him to finish to if we're doing continuous deployment, he's merging into main. I have to wait for him to merge into main before I can start my work. using Code Zero, what I can do, and I talked to Dee Dee about this in her talk, is that I can use route traffic to Andrew's backend. So I can actually sit there in real time. We can be sitting there on Slack going like, hey, can you add me, you forgot that endpoint, or oh, whoops, that didn't come back right. And I'm using the code that's running on his laptop with the code that's running on my laptop with the shared services that are running in the Kubernetes cluster. That now we have that quick feedback loop of development that you don't get in any other environment. Like the only way that we could do that would be pair programming on the same laptop, and four hands don't work on a keyboard, right? So that kind of flow as a team is really cool. All right. Well, thanks everyone. I really appreciate you coming. Enjoy the conference. And if you have any questions, I'm around all day. All right, thanks.